A very good morning to all of you children. In last class we have discussed about kinetic energy, and as I have explained that the energy possessed by a body due to its motion is called kinetic energy. And then we have derived an expression that Ek is equal to half mv square. We have also seen that sometimes the work done is responsible for the kinetic energy. So we have also written W is equal to half mv square. Sometimes work done is responsible for change in kinetic energy. So we have written W is equal to half mv square minus v square. So all these formulas are important, and you have to apply these formulas to solve the numericals. Now today we will discuss about potential energy. So let us start potential energy. So first, what potential energy is? So potential energy is the energy possessed by a body due to its position or condition. Position or condition means, suppose there is a stone on the earth's surface. So on earth's surface it has no energy. But if you lift the stone and just place it to some height, suppose you place it on the second floor of a building, then it acquires energy. It acquires energy because if it will fall from that height, then it can hurt someone. So it acquires energy when we change its height. Another example, suppose we stretch a rubber band and then release it. So it will cover some distance. So when we just change its condition, it acquires some energy. Another example, if you compress a spring and then suddenly release it, the spring will jump. So due to position or condition, some objects acquire energy, and this type of energy is called potential energy. Example is given in your book. You look at figure 11.6, that an arrow and a string on the bow. So that arrow acquires energy because when you release it, it will cover some distance. It acquires energy when we stretch it on the bow. So write a definition for it. The energy possessed by an object due to its position or condition is called potential energy. You will write some examples, write 2-3 examples, that a compressed spring, a stretch rubber band, a stone placed at some height. In this way, so many examples. So these are few of them. So in this way, you can say that the object acquires energy when its position is changed or its condition is changed. Then we will derive an expression for potential energy. So potential energy of an object at a height. You must write these things in your class for copy. Potential energy of an object at a height. Now I am reading these lines from book. An object increases its energy when raised through a height. As I have explained earlier, suppose you take a piece of stone and place it on the first floor of a building, it will acquire some energy. When you increase its height, suppose you place it on the second floor of the building, it will acquire more energy. So its energy increases as we raise the height. This is because work is done on it against gravity. So why energy increases or why it acquires energy? Because we are doing work on it. So is it clear how we are doing work on it? First, to lift the stone, you have to apply some force, and that force must be equal to its weight. So first you lift the stone and then place it on the first floor. So you increase its height. So that work done which you will do on that piece of stone, that work done store in it in form of energy. Because if you will allow this stone to fall from that height, it can hurt someone. So we are doing work done against gravity, isn't it? As you know, the gravity or the gravitational force of earth, it acts in downward direction, and opposite to it we are lifting the stone and just putting it in first floor or second floor like this. So we are doing work against gravity. The energy present in such an object is the gravitational potential energy. So if we are doing work against gravity, and due to this work, if object acquires energy, then this type of energy is called gravitational potential energy. So gravitational potential energy, first write a definition for it. Gravitational potential energy. So write a definition for it. Write down the gravitational potential energy. The gravitational potential energy of an object. The gravitational potential energy of an object at a point above the ground, at a point above the ground is defined as the work done in raising it, the work done in raising it from the ground, from the ground to that point, from the ground to that point against gravity, from the ground to that point against gravity. Now we will derive an expression for it. So expression for gravitational potential energy. To derive an expression, first draw a diagram. Suppose this is Earth's surface, this is ground, and let an object is on the ground. Now we raise it to certain height. So suppose now object is here. So this height, suppose this height is h, small h. Let the mass of object is m. Initially it was on the ground and we lift it to a height h above the ground. So if we lift it to a height h above the ground, how much work done we are doing? So for work done, no need to write now, try to understand. As you know, work done is equal to force into displacement. This basic formula we have discussed earlier. Now what is the force and displacement here? So force, how much force you are applying on it. So here the force is the weight of the object, isn't it? Because to lift the object you have to apply a force which is equal to its weight at least. So its weight is the force. So this force is equal to weight in this case, and then displacement. Now we know that this weight is equal to m into g, where m is mass of the object and g is acceleration due to gravity. And displacement is how much? From ground to a height h. So you will observe that how much work we are doing on it to lift it to a height h. That work done is mgh. Now due to this work done, it acquires a energy of mgh unit. So this work done is equal to potential energy of the object. So we will write that EP is equal to mgh. So again, very important conclusion, that work done is equal to kinetic energy, that we have learned in previous class. Now work done is sometimes equal to potential energy, and this work done is responsible for potential energy. So potential energy is equal to mgh. So I think it is clear to you children. So write about it, because you can get a question, derive an expression for potential energy. So write it. Considering an object, write down, considering an object of mass m. Considering an object of mass m, let it be raised. Let it be raised through a height h. Let it be raised through a height h from the ground. From the ground. Then write, a force is required. A force is required to do this. A force is required to do this. Then write, the minimum force required to lift the object. The minimum force required to lift the object is equal to the weight of the object. The weight of the object, that is mg. That is mg. The object gains, next sentence, the object gains energy equal to work done on it. The object gains energy equal to work done on it. Let the work done against gravity, let the work done against gravity be W. Let the work done against gravity be W. Then work done, now write down, work done is equal to force into displacement. Now this force is equal to weight, in this case weight of the object into displacement. Now how much is the weight of the object? Weight is equal to mg and displacement is h. So we can write W is equal to mgh. Right? Since work done on the object, since work done on the object is equal to mgh, and energy equal to mgh units, and energy equal to mgh units is gained by the object, This is the potential energy of the object. This is the potential energy of the object. Hence, we are writing EP. E stands for energy and P stands for potential. So, EP, it means potential energy is equal to mgh. So again a very important derivation, that potential energy is equal to mgh. Now reading the lines, page 153 right side from the beginning of the paragraph, it is useful to note that the work done by gravity depends on difference in vertical height of the initial and final position of the object, and not on the path along which the object is moved. So look at the diagram 11.8. There are two diagrams. In figure 1, the path is straight and the height is h. In another diagram, you see the path is not straight, it is zigzag, but the height is same, height is h. So the potential energy does not depends on the path, it directly depends on initial and final position of the object. It means straight line, distance or the height. So in both the cases potential energy is same. Now children, we will discuss some of the numericals based on potential energy. So the first question is, a boy weighing 40 kg. I am writing this question. Question 1. A boy weighing 40 kg climbs up a vertical height of 200 meters. Calculate the amount of work done by him. How much potential energy does he gain? And G is given 9.8 meter per second square. So let us solve this question. First write down the given things. So a boy weighing 40 kg. So mass is given 40 kg. Height is given 200 meter. So you have to calculate the work done. How much work we have to do, how much work the boy is doing to attain a height of 200 meter. So as we know, work done is equal to mgh. So G is also given. So mass is 40 kg, G is 9.8, and H is 200 meter. So multiply these. So 40 into 200. It will be 8,000 into 9.8. So 72,000 joule. This much work done. Now this work, due to this work done, he gains energy, right? Due to this work done, the boy gains energy, hence potential energy is also 7,200 joule. Must write the unit. I think it is clear to you. Now the next question. I think you all have written. Now next question is question number 2. Suppose two bodies suppose two bodies A and B having equal masses are kept at heights h and 3h respectively. Find the ratio of their potential energy. So this is another question. So first you have to calculate the potential energy of body A and then potential energy of body B. So potential energy of body A will be mgh, because they are of equal masses, so let their masses are m. Similarly, potential energy of body B, say equal masses, it is given in the question, so we will write again m into g, but this is at a height 3h, so in place of h we will write 3h, so this can be written as 3mgh. Now you have to find the ratio of their potential energy. So potential energy of A divided by potential energy of B. So mgh divided by 3 mgh. mgh cancel, so you will get 1 by 3. So this ratio is 1 is to 3. So this type of questions you can also get, children. Write it in your classwork copy. I think you all have written. Now, third question. Question number 3. If an engine supplies 100 joule of energy to a weight of 200 gram, how high it can be lifted? G is again given 9.8 meter per second square. So here amount of energy is given, that is 100 joule, and due to this energy the object acquires some height. It means it acquires some height, it means it acquires potential energy. So we know that EP is equal to mgh. We know that EP is equal to mgh, and EP is given that we are supplying 100 joule of energy. Mass of object is given in grams, so convert it into SI unit. So 200 gram, convert it into kg, so divide it by 1000. G is given 9.8, and H you have to calculate how high it can be lifted. So it will be 100 cross multiplication into 1000 is equal to 200 into 9.8 into H, or we can write H is equal to 100 into 1000 divided by 200 into 9.8. So this 0 cancel. If 1000 is divided by 2, you will get 500, and remove this decimal, so it will be 5000 by 98, and further cut it, it will be 49 if we cut it by 2, and this is 2500, so 2500 by 49. Try to simplify it. So if you will simplify, it will be nearly 51 meter. We are getting 51.0 something, so roughly you can write 51 meter height. So these are the different types of question that can be asked. Some questions are given in example in NCERT book. You must go through it. Example 11.5 and 11.6. In homework must solve it. Example 11.5 and 11.6. Must try yourself first, not simply copy it from the book. And if unable to solve it, then see the solution and then close the book and try to solve it. Now we will solve some more questions. So question number 4. Question 4 is a body of mass 2 kg is thrown vertically upwards with an initial velocity of 20 meter per second. What will be its potential energy? At the end of 2 second. G is given 10 meter per second square for this question. So in this question we have to calculate the potential energy. Now to calculate the potential energy, what things are known to you? First, mass of the object, mass is given. Then acceleration due to gravity, g, that is also given, 10 meter per second square. And third one, height. So height is not given in this question. So you have to calculate the displacement, how much height it will acquire when we throw it with a velocity of 20 meter per second. So the given things are mass 2 kg, u is given, initial velocity is 20 meter per second, and we know that whenever an object is thrown upwards, its final velocity is 0. So v is 0, and you have to calculate potential energy at the end of 2 seconds. So time is given 2 seconds, g is given 10 meter per second square. So first thing, which equation of motion you will apply to calculate its height? So you can use, time is given, so you can use second equation of motion. So the second equation of motion, h is equal to ut plus half gt square. Use this equation. So we will write u is 20 into 2 plus half, g is 10, and t square, it means 2 square. So if you will simplify, it will be 22 is 40 plus 2 5 is 10 and 5 4 is 20. So 60 meter. It will acquire a height of 60 meter. So after calculating height, it is easy to calculate the potential energy. Now as we know, potential energy is equal to mgh. So mass is 2 kg, g is 10, and height is 60. Multiply these numbers. So 600 into 2. So 1200 joule. So this is another type of question. So you can get different type of questions. That's why I am solving the possible questions which can be asked. Some more questions are left. So I will discuss these questions in next class, but you must remember all the formulas which are very important to solve the numerical problems. And a quick revision of these formulas. First, we have derived work done is equal to force into displacement. Then second formula which we have derived, that work done is equal to half mv square minus u square. Third, we have derived work done is equal to half mv square. Fourth formula we have derived that kinetic energy is equal to half mv square. Fifth formula which we have derived, that work done is equal to mgh. And sixth one, that potential energy is equal to mgh unit. So must remember these formula which we have derived earlier, because all numericals are based on these formulas plus equations of motion. We have to apply it everywhere, whether it is gravitation chapter, in force and laws of motion we are also applying, and here in work and energy also. So this much for today, children. In next class we will discuss some more numericals and law of conservation of energy also. Thank you.